if there's anything the new coronavirus taught us, is that we need to be self-reliant. We need to look inwards to be able to come up with solutions ourselves. What got me to take up this challenge is that it was at a time that borders were closed, countries were having to look inward.
At the beginning of this crisis, my understanding was that there were only 67 ventilators in the country. And as you know, there was a global panic as to what this pandemic, the outcome of this pandemic was going to be. So we just started working on trying to develop a system for ventilation so that in the event that the crisis actually hits, there will be a way to remedy the situation. So I sent a call out on Facebook and I had over 100 volunteers who responded to the call. The students came from home. We picked some all the way from Koforidua and drove them down here under a special permit. And then we had our technicians who were diligent and stepped up to the plate. So it was volunteers and students pulling together resources to make this happen.
I joined the project because I saw it as a form of community service, like volunteering to help solve a problem. And also because of my keen interest in design and manufacturing, I joined to learn more on it.
My role on the project has been more of the person in charge of electronics controls and logistics, I should say. I am also the person who is mostly in charge of coming up with the circuit designs and what each parameter we are working with should be. And a lot of the logic programming also happens with me.
In the team, I'm the CAD/CAM technician. That is basically I build prototypes, simulate the prototypes, and then sometimes too I assemble certain prototypes.
We take the dimensions and we sketch the models in SolidWorks. Then we simulate and see the materials we can use, the effects of forces on the parts of the ventilators and other.
The designs they came up with, which they modeled in SolidWorks, was the same design that we ended up putting in a 3D printer to actually print some parts. I think they played a very, very critical role. And this goes to show that, you know, engineering is not just for men, it's equally for women.
So the initial intent was to come up with something that was easily assemblable locally. Parts were local, we could react very fast to put a series of these systems in the field. I think in that regard, we were quite successful. Most of the components we used were harvested from existing systems locally. Used a motor from a windshield wiper system. We came out with bellows from ladder. So I think overall, what we set out to achieve was a low-cost ventilator, and we were able to do that. If you're an engineer, everything that you design could be designed for the first time, right? Anytime you get an opportunity to step in and do something, it will be for the first time. And so really trying to understand the basic sciences, the physics, the chemistry, the biology of the problem is fundamental. And then, you know, guiding the students through each of these separate components. How do you bring such systems together to design product? You need to understand the disease. You need to understand the remedies. You need to understand what has already been done, and just trying to tread very nicely within this framework to find out systems to put in place that solves the problem. So engineers never get a chance to just do old stuff. They also get good chances to do new stuff, which means you have to think, you have to apply the knowledge that you have in the classroom and go out there and field test it.
So on this project, I've had a variety of experiences, and the most important one for me has been how to appreciate the efforts of people working in teams.
It has given me an idea of how the engineering industry is going to be. And at first, I thought engineering was just a linear way. You just plan a concept and then you develop a product. But working on this project, we were made to make changes, several changes on the product. We were constantly learning, trying to understand the way things work, just to develop a prototype.
You see, I do mechanical engineering, and there are some things in computer engineering and electrical that I don't really understand. So when it comes to those things, you ask and there is someone there who will help you out. And with that, we're able to finish lots of tasks within a short time.
We had a bunch of supportive lecturers. Each time we meet a stumbling block, they are able to just jump in and help us. There have also been people who have given us stuff that they were using at their work. An example is Botin, the eyeglass company. They gave us their 3D printer, CNC, all in one machine, so that we could use them to build the parts we needed when we couldn't find parts.
Mostly the challenges were logistics challenges, where to get components, where in town. At times when we needed something from abroad, it was quite challenging. So I think, the lessons learned is that there has to be local manufacturing, there has to be local technology development, because in times of crisis, nations tend to be a little more inward looking. And we saw the fullest impact of that you couldn't import anything from outside Ghana. And so we try to focus on low-cost material systems that we could readily assemble to build these systems. Here's the system. As you can tell, it's really made from local materials. This is wood. Once we give it a nice finish, it will look like a metal. But for now, it's easy to find. You can find wood everywhere in Africa. We have sliders here that are your typical carpenter sliders. There's an ambi bag here that you typically see in emergency vehicles. We have an oxygen tank here, and some electronics in the back, which I'll flip soon. But what we tried to do was to design something that was easy, portable, could move around easily in the vehicle. As you can see, your lung is inflating up, and we have a PEEP container here that ensures that the lung is not collapsing back. You can either use the ambi bag by itself, where you get medical air, or you could also use it in conjunction with oxygen. And so the person is getting the full range of aeration, getting both oxygen and medical air. It's a pretty simple device. If I flip it over, you will actually see your 2 backup batteries, and this was intentional so that you can actually use this in remote areas where there is no access to power, right? On your way to the hospital, if you run out of battery power or battery charge, you can actually hook this up to your cigarette lighter in your car. Very simple, nice simple cover, right? With some air vents here for it. So essentially, this is our system. We think it is small, it's portable enough that you can put this in an emergency vehicle.
Looking at our students, if I were to assess how they did, I think they've done phenomenally, because a lot of us had a background in mechanical, so we were able to come up with the top level design of how the ventilator should work. Working alongside with the Ghana Health Service, with Kolibu Teaching Hospital, we were able to understand the medical aspect. But what our students brought on board was the control system, how we could automate the whole process, how the device we're coming up with was going to be adaptable. All that was on our students. Our students have done phenomenal.
I'm really grateful that I've had the opportunity to be in a place where I not only learn about how things work or just play with stuff, but I'm able to intertwine theory and practicality to build actual solutions.
You should believe and trust in yourself. You have it within you to come up with innovations and inventions. And if you were to join an institution such as Academic City, you'll be given the skills, the technology, know-how to be able to come up with inventions of your own, so that you don't have to wait till graduation to actually make an impact. You can make an impact even whilst you're in school.